Jumping into section 3.3, there's again we're kind of using graphs to gather data about a function. So again, this is going to be very visual, very graphical in nature, but there is some algebra behind it and some instances, as we'll see. But one of the main ideas that we're going to revisit is this idea of increasing and decreasing. And from there, that takes us to what we call absolute extrema. But first, let's talk about increasing and decreasing. Again, very, very visual. I'll talk about math-wise in a moment. But just looking at a graph, here's a parabola right now. We can pretty much see that the graph is essentially on its way up until we hit that point right there, and then it's basically on its way down. So when we're on our way up, we're essentially increasing, and when we're on our way down, we're essentially decreasing. And so that is pretty much it. Again, very visual idea. We'll talk about how to write our answers in a moment, but just looking at the pictures, okay, again, for this graph, the graph is pretty much on its way down. So we're decreasing. We kind of hit this low point, and then the graph is basically on the way up. Oh, and I might add, we're moving left to right, right? So we move along the x-axis left to right. So as I do that, we're on our way up, and then we're on our way down. Here we're on our way down, and then we're on our way up. So decreasing and increasing. Let's just kind of keep with this visualness in the next graph. There's a lot of changes, but as we move left to right along the x-axis, the graph is going up. So we're increasing for a phase, and then we hit a high point, and then we go down. So we're decreasing for a phase, and then we hit a low point, and then we're on our way up, and we're back to increasing. So this one, increasing, decreasing, increasing. And then last but not least, as we go from left to right, this graph again goes on forever, the graph is basically on its way down. So notice as I trace, I'm going down, 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 down. We're almost negligible here, but there's no action actually having me go up. So this guy, right, seems to be decreasing all the time. It's decreasing very sharply to begin with, and then it starts to slowly, the rate of decreasing starts to slow as we go. So there again, very visual idea what it means to increase and decrease. Basically, my graph is on its way up, and my graph is on its way down. Okay, so now that we kind of have the visualness down, let's look at the algebra behind it. Mathematically speaking, so you understand the answers that we do, right? To be increasing, that means that if I have an x1 that's less than an x2, right, in my domain, and this would mean that f of x1, right, will be less than f of x2, right? And this is for all x's in a part of a domain. All right, and I stress part because as you notice, we're not always increasing or always decreasing. So the idea here is if I have an x value that's to the left of another x value, so like let's say -7 and -5, just to give us some values. So notice that the function value at -7 is less than the function value at -5. So the function value at -7 is here. The function value at -5 is up there. So because the function value at -5 is, or the function value at -7 is less than the function value at -5, that means that for all x in that part, right, we are pretty much on our way up. And so that's what it means to be decreasing. So when I'm talking about increasing, what we're talking about is we're talking about intervals in the domain. All right, so so where in the domain is the action going upwards? And so when I look at this, the way I would answer this function is basically increasing from -infinity all the way up to 3, right? So again, it's going down for forever, but again, we would pick up the graph down here, and then it's basically on its way up. So for all x's from -infinity up to this high point, the function's pretty much behaving the way that definition says. If I have a value to the left of another value, then its function value is smaller than the other function value at that. Okay? Same thing over here. When are we increasing? You know, notice again if x is 2 and x is 7, the function value at 2 is less than the function value at 7. And this happens throughout, right, all the x's in that part of the domain. So this guy would be increasing starting at 0 and going to infinity. So at x equals to 0 and forever and ever and ever, the graph is basically on its way up. So again, we're talking about domain intervals where the action's occurring. This one, again, we have some, we start from negative infinity, we reach a high point around negative 2, right, and then we start decreasing, and then we reach a low point at about 2, and then we're increasing again. So the action of increasing is happening on that stretch of the domain and on that stretch of the domain. So if we're less than negative 2, the action of the function's up. If we're greater than positive 2, the action's on the way up. And then this guy, right, the answer would be never, right, because we've already went through that it's constantly on its way down as we move to left to right. So increasing, right, you would say never or not defined or whatever the case might be. I think the fact that it's never increasing pretty much puts that into bed. So to answer the increasing decreasing question, again, we're talking about intervals along my domain where that action of increasing happens or where that action of decreasing. Again, mathematically for decreasing, we're saying that if I have an x1 that's less than an x2, right, so I have a value of x to the left of another value of x, then the function value at x1 is larger than the function value at x2. And so that's, and this is for all x in a part of the domain. So you can kind of see that happening here, right? So let's use negative 6 and negative 2 as our x1 and x2 right there. So the function value at negative 6 is bigger than the function value at negative 2. And that action occurs everywhere, right? So this is decreasing starting from negative infinity to 0. So the function's on its way down. If my input's over on this side, the function's pretty much on its way down. So we are decreasing. Same thing over here, right? If we consider negative 2, its output's up here. If we consider 1, its output's way down here. So negative 2 is to the left of 1, but its function value is bigger than the other function value. So that means mathematically we are on our way. We're on the way down on that section of the domain. So we are decreasing from negative 3 to infinity for that graph. So again, where in the domain am I on my way up? Where in the domain am I on my way down? Here, it looks like we're on our way down in terms of decreasing, right, starting from negative 2 to 2. So we're on our way up from negative infinity to negative 2. We're on our way down from negative 2 to positive 2. And then we're back on our way up. And then, of course, this guy is always decreasing. So the interval of its decreasing is from negative infinity to infinity. So that wraps up our first initial idea, and it turns out that this concept of increasing and decreasing also happens to help us with some extrema ideas, but I'll cover that in the next video. But to wrap this up, again, I think very visually it's kind of obvious when we're on our way up or down, but what's not obvious is how I write our answers, right? The answers for the increasing decreasing question are intervals along my domain. And so we're basically going to be using interval notation to represent the parts of the interval where I'm on my way up and the parts of the interval, part of the domain where I'm on my way down. Alrighty, so more coming up a little bit later. Let's keep diving deeper.